A feather and a hammer dropped and left on the moon may be seen to represent thousands of years of development of thinking towards our understanding of nature. It is fitting to start a course on physics, an introduction to physics, with the moon, in particular our visit to the moon, humans' visit to the moon, more than 50 years ago.
At 15 seconds, guidance is internal. 12, 11, 10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. We have a liftoff. Liftoff on Apollo 11.
It is fascinating to imagine that some humans have traveled there. And that was possible because of the physics that explains why the hammer and the feather fall the same. This is because the moon does not have an atmosphere, and the feather and the hammer fall in vacuum. And indeed, it was one of the first realizations of physics that all objects fall the same if drag can be neglected, and that is the case on the moon. Physics has let us travel to the moon and back using the same ideas and concepts of mechanics that describe the fall of a hammer, of a feather, on the moon, or for that matter on Earth, and in fact in the entire universe. This demonstrates how powerful the concepts and laws of physics are. Physics is about the fundamental principles that underpin nature, with a focus on forces and on energy. Physics is a foundation science for other disciplines, such as chemistry, biology, and all the engineering disciplines. Physics also thrives on the interplay of experimentation and measurement on one hand, and theoretical modeling on the other hand. And the language of physics is mathematics. No physics without mathematics. Mathematics is the one precise and concise way of discussing and defining physics. The name of the science of physics has its origin in ancient Greek. Physike episteme, that's Greek for knowledge of nature. So the name physics says exactly what physics is about, the knowledge of nature. While humans will have always contemplated nature and would have sought explanations, a distinct starting point of the science of physics may have been the academic and published work by Aristotle, who lived in the ancient Greek world. Aristotle introduced the concepts of motion, kinematics, the science of motion, and force, dynamics, the science of the force. He also theorized about relationships between forces and objects and speculated on causes for the motion of objects. Importantly, in striking contrast to our modern approach, his physics did not involve experimentation and measurement. His physics was restricted to logical, philosophical thought only. These are some of the postulated ideas that Aristotle philosophized about. Objects move to their natural place. For example, steam, which is a gas, moves to the sky because that's the natural place for a gas. Motion requires a force, is a claim that Aristotle made, and that persisted for nearly 2,000 years. Heavy objects fall faster than lighter objects. Solids objects fall because their natural place is Earth. They fall to the ground. While there is some systematics in this approach to nature, it is clear already that some of these ideas are not correct. For example, Aristotle's approach to physics would suggest that a feather would fall much slower to the ground than a hammer does. Indeed, that's what we observe on Earth. However, that's not the fundamental truth, which has been demonstrated by dropping hammer and feather on the moon, where they fall the same, and you can do the same in vacuum on Earth. All objects fall the same in vacuum. That's the fundamental truth. And it took almost 2 millennia from Aristotle until the Renaissance that humanity could make that realization. The reason for Galileo's success is that he combined philosophizing and theorizing, that's what Aristotle did, with experimental verification and measurement. Theorizing, theory, and experiment go hand in hand, and that became the foundation of the empirical science of physics that we know today. And now we understand that fundamentally all objects fall the same. And if they don't, as we observe on Earth, then there must be some other physics at play, such as drag.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. Oh, wow, watch this. Joe, you have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.